The skeletal system is also well adapted after a long period of time to anaerobic exercise. The osteoblast, osteoclast, and osteocyte activity is all adapted. Osteoblasts move to the surface of the bone, helping to make it more dense and allowing the making of new cells at the periosteum. Anaerobic exercise can often be involving weights, which helps increase the width, density, and strength of bones. In long bones, osteoblasts carry out ossification, which turns fibrous tissue or cartilage into bones. This is better for weightlifters, as it makes their bodies stronger and less prone to injury. Osteoclasts break down the bone and reabsorb calcium, which helps them complete bone remodeling, where they regulate bone growth. Weight exercises also help to prevent osteoclast activity, which helps to keep a healthy bone density and stops bones from deteriorating. Long-term exercise slows the skeletal aging process, which in turn prevents older people from developing debilitating conditions such as osteoporosis, where the bones become too weak. People who keep an active lifestyle have a greater bone mass, stopping this from developing. It is also common to find older people that have osteoarthritis and have osteoporosis. Regular exercise can help to decrease the likelihood of this developing. Another adaptation that comes with long-term exercise is the addition of collagen and increased strength in the tendons. These weight exercises cause micro tears to connective tissue where collagen is found, and the body can adapt by regenerating new tissues made of protein that is mostly collagen, as collagen is the most common protein in the human body, which gives bones its flexibility and helps bones resist tension. This allows the body a greater range of movement, and this kind of adaptation is made without the use of weights as well. It just occurs naturally through regular exercise. Joint pain is also reduced during and after exercise because physical activity boosts the circulation of synovial fluid, which is used to lubricate joints. Exercise also moves water molecules that put weight on the joints and cause pain. Articular cartilage and ligament strength also improve to help support the body. Contrastingly, if an athlete overtrains or strains their skeletal system, they can cause permanent damage to their joints. The same goes for if an athlete does not allow the body enough time for recovery. An anaerobic athlete must be able to adapt their bodies so that they can perform to the highest ability during their race. This is so their body can adapt to the training, physical demands, and conditions. For example, during any form of long-distance event like a marathon or triathlon, athletes must have the ability to work at a submaximal intensity for a long duration. The body needs to have a high VO2 max, which is the maximum amount of oxygen your body can use during intense exercise. They must also have a high lactate threshold, which is the fastest pace you can run without generating more lactate than your body can get rid of. Lastly, these elite athletes must have an excellent running economy, which is the body's ability to make efficient use of resources to cover the distance. Endurance activity keeps your heart, lungs, and circulatory system healthy and improves your overall fitness. As a result, people who get the recommended regular physical activity can reduce the risk of many diseases, such as diabetes, heart disease, and stroke. Most adaptations that take place to the cardiovascular system take place during aerobic exercise. This is because the heart is required to pump oxygen around the body at this time. The entire cardiac cycle adapts itself by increasing the size of the heart and its chambers. This allows for a larger stroke volume and it lowers the body's resting heart rate. Therefore, there is a greater cardiac output, which allows an athlete to continue working at their chosen intensity easily. Cardiac hypertrophy, where the left ventricle has increased in size, lowers systolic blood pressure because less arterial pressure is needed to pump more blood through the aorta. Because of the increase in blood flow, there is an increase in blood volume. This allows the cardiovascular system to be more efficient and deliver more oxygen and nutrients to the working skeletal muscle. Continuous training also causes an increase in the activity of the parasympathetic nerves by decreasing the sinoatrial node's firing rates. This links into the lowered heart rate. The blood itself in the body also changes after exercising aerobically, because this exercise increases the amount of protein in the blood plasma, which causes water retention that increases the blood volume. It also increases the amount of red blood cells, also known as hematocrit count, in the body. Our red blood cells carry oxygen, so if we can carry more of them, then our muscles can be supplied with more oxygen, allowing them to work for longer. After a long-term aerobic exercise plan, the blood in the body becomes less thick and the viscosity decreases. The body's arteries are prevented from hardening, which means blood can flow easily. This amount of exercise also stops the buildup of fatty deposits, which can cause heart attacks. The number of capillaries located around the body increases, especially around the heart and the skeletal muscles. This helps to allow for more diffusion of oxygen moving from the blood into these muscles. It also helps to remove carbon dioxide. The heart requires extra capillaries to diffuse oxygen into it, as the heart itself is a muscle that requires oxygen to pump itself before it pumps the rest of the blood around the body. Taking part in regular aerobic exercise lowers the likelihood of you developing a disease like coronary heart disease, heart failure, or suffering from a stroke. This is because the cardiovascular system has become adapted to work better and strengthen your heart muscle, lowering your blood pressure and raising your high-density lipoprotein levels. In the graph on the screen, it shows the difference between an athlete's heart rate before and after a training program. This exercise can cause an athlete's heart rate to increase dramatically, which is shown in the graph. Pre-training, the athlete's resting heart rate was much higher than it was after the long-term training period. This is because the person's cardiovascular fitness increases. When exercising, their heart rate remains near enough the same level as they are still working as hard as possible and reaching their maximum heart rate. However, post-training recovery is much quicker as the body has managed to adapt to these changes. Elite athletes like marathon runners are shown to have a far larger number of red blood cells in their body due to their muscles needing a large amount of oxygen to continue running for a long period of time. The size of the walls in their left ventricle are also shown to be much thicker than those of someone who does not perform aerobic training. This is cardiac hypertrophy and allows the athlete to pump more blood in one heart contraction. This graph shows an athlete's heart rate during continuous steady-state exercise. Every time the intensity increased, the heart rate did correspondingly. This is so the heart could pump enough oxygen into the muscles that needed it. After a training program, an athlete's heart rate should decrease, as their blood will have more red blood cells and their left ventricle should be slightly thicker. These changes do take a long time to occur though, so it would take a long time and a lot of training for these results to go down dramatically. There are far more respiratory adaptations after long-term aerobic exercises than anaerobic exercises. This is because the body requires the lungs to take in oxygen to the red blood cells and remove more carbon dioxide. The body overall becomes stronger. This is the same for the respiratory muscles, like the external intercostal muscles, which can produce a greater contraction while the internal intercostal muscles relax. This forces more air into the lungs during inhalation. The larger the contraction of the internal intercostal muscles and relaxation of the external intercostal muscles to expel air, the greater the air inspired will be. Tidal volume can be increased to around 1 litre for an average adult. This is nearly double what is at the regular resting rate. This is a good adaptation as it means the body is taking in more air per breath, therefore more oxygen. The body's vital capacity also increases, which allows for deeper breaths that contain more oxygen. Residual volume increases in proportion to the other increases. The body also allows itself to adapt by increasing its whole respiratory rate to deliver more oxygen to the working muscles. However, Because an athlete's tidal volume begins to increase after long-term exercise, an athlete's respiratory rate can decrease during normal breathing, but is able to process larger amounts of oxygen at higher breathing rates. This is far more economical for athletes. Taking deeper and slower breaths also means that alveolar ventilation is increased. Alveoli in the lungs, where gas exchange takes place, are also able to grow and produce a large surface area for more and quicker gas exchange. The oxygen deficit is therefore decreased as the body is able to take in more oxygen, creating a quicker epoch or recovery time. Taking part in regular or long-term aerobic exercise helps to control or regulate conditions such as asthma and cystic fibrosis, as exercise slows the rate of the decline in lung function, which means children with CF may keep good lung function for longer. It helps to clear mucus from the lungs, allowing for easier breathing. Elite athletes like marathon runners can have an adapted tidal volume of around 2 litres because their skeletal muscles require lots of oxygen a lot of the time. These trained athletes also have a larger ventilation, which can be increased by 50% to 150 litres per minute. The test results from steady-state exercise show an expected anticipatory rise, as the performer was probably nervous and preparing themselves for the test. The breathing rate then increased as the body is required to work harder. The more exercise done, the more carbon dioxide and hydrogen levels increase and the oxygen levels decrease. This means that the ventilation levels increase and so do the tidal volumes. Our bodies demand more oxygen as the chemical levels in the blood change. The chemoreceptors detect it and send signals to the respiratory control centers. This in turn increases our breathing rate and tidal volume. At the end of the test, the athlete's breathing rate has increased in order to continue to supply the body's vital organs and muscles with enough oxygen to function during this aerobic respiration. After a training program, an athlete's breathing rate would be expected to decrease as their tidal volume will be greater, therefore preventing them from getting as fatigued and needing to take as much oxygen. After aerobic training, the neuromuscular system makes some slightly alternative differences to the body than after anaerobic training. For example, increased motor unit synchronization, but specifically slow oxidative or fast oxidative fibers. There is also a decrease in the force threshold at which motor units are recruited, allowing the body to contract its muscles more easily. There is also an increased amount of myoglobin stored in the muscles, meaning there is more oxygen stored. When oxygen combines with myoglobin, it forms oxymyoglobin, which is an oxygen storage site for when the body is oxygen deprived. This allows the body to contract its muscles for longer without fatiguing. There is also an increase of mitochondria in the cells, meaning that more ATP can be produced, allowing for more contractions. Aerobic endurance training will increase muscular endurance for muscles that are used in this specific training. During the swimming portion of a triathlon, all the muscles in the athlete will be working hard and be adapted as they are all in use. However, during training for the cycling portion, more muscular endurance of the lower body will be developed.